Hello everyone. In today's video we're going to talk about a trigonometric identity which will take us away from the graphing of trigonometric functions and more towards actually seeing trigonometry in action, seeing it used in proofs and to establish some really powerful formulas. So today we're going to talk about two formulas and I'm going to show you how to derive one of them. Okay, so I opened up a Google Drawing so I can show you these two formulas. There's a couple other ones, but I'm going to show you these two first. And I'm going to show you how to derive them. Where do they come from? So if you're familiar with constructions from geometry, this is very, very similar. So I'm going to go ahead and select my line tool. And I'm going to start off by drawing a horizontal line. So this line represents my x-axis. Okay, and I'll go ahead and put some arrows here. Just like that. Now, on this line, we're going to go ahead and put a dot just to represent the origin. This dot is where the y-axis would cross. We don't need a y-axis for this construction, but if there was a y-axis, it would cross right through there. So this dot is the origin. We're going to go ahead and label this O for origin. Let's put that up. Okay, so there exists this line with this point O. Now let's go ahead and make an angle, which we're going to use to take the sine of. So let's make an arrow. And just like that, let's go ahead and thicken it up a bit. So this arrow is just going to be any angle, really. We have this angle here. And we're going to go ahead and, oops, we're going to draw another line. Let's say this line here. Oops. Let's get rid of that arrow. Okay. So this line represents the sine of this angle. Okay. Now, we're going to give these points names just so that we know what we're talking about. Let's give this point where it's intersecting. Let's give this name, this P. So that's this point right here. And then let's go ahead and let's make this point B. Okay, we're just building right now. We're not necessarily solving anything. I'm just showing you how this formula is true. So this isn't necessarily solving a problem or anything. I'm just kind of building a triangle. So we've got this triangle here. Again, this is my x-axis. We have an angle here, and this line segment from P to B. So we can say that the sine of this angle, if we say that this length is 1, then that is going to be a length of sine of the angle. Okay, so let's go ahead and draw another arrow. Something like this. Okay. So we draw another arrow. We're going to call these two angles different names. So this angle here, the top one, we're going to call that angle B. And the bottom one, we're going to call that angle A. So you can see I have made these two angles A and B, which corresponds to what we're doing up here, sine of A plus B. So sine of A plus B right now, we would say it's this length, right? Because this hypotenuse here, this is 1. So we're building a scenario where we can see the sine of an angle A plus an angle B. Alright, next, we're going to go and we're going to draw a right angle here. Let's see, right here. So we're going to draw a right angle right there. So this right here, this is a right angle. Okay, we've just made another right triangle. Let's see if I can adjust this here. Okay, so this is a right angle right here. 90 degrees. Okay, now we're going to draw another line from here right down here. Okay, this one's also 90 degrees. We're going to give these a couple of different names of these points. So we're going to call this one A, right here where these 2 points intersect. And we're going to call this point point Q, where these ones intersect. Okay, almost done building. We just need one more line. So we're going to draw a line from point Q right across, oops, like this. Okay, and this point right here, let's see if I can zoom in. There we go. So this point right here, where this is intersecting, we're going to call this point R. Okay, that's this point, this spot right here. This is also another 90-degree angle. Okay, now I'm gonna spit out some truths here. So we know that this is angle A, and we can see that triangle OQA, so triangle OQA, this is a right triangle. Okay, so this is 90 degrees right here, and A is some number of degrees, we don't know, it doesn't really matter, and therefore the angle here from O to Q to A, right, this one right in here, okay, this is going to be the leftovers, so this would be 90 minus A right in here. So I'm going to make a little note here. Let's see if I can reduce. Okay, that's this angle right there. Now, if this angle is 90 minus A, then this small little angle, oops, right here where my cursor's pointing, this angle right in there, okay, this is making a 90-degree angle right here. You see where my cursor's moving? From A to Q to R. That's making a 90-degree angle. So therefore, if this is 90 minus A, then this little angle right, come on. Anyway, this little angle right in here, really, really small, is also going to be A. Okay. Now, if that small little angle is A, then this angle here, okay, from P to Q all the way down to O, is another 90-degree angle. We know this tiny one is A. That means this one is also 90 minus A. Okay, so this one is also 90 minus A right here. That means this little slice right in here, which is A, that's the angle A, can either be put together here with this one and make a 90 degree here, or it can be put together with this one and make a 90 degree here. Okay. Finally, because this is a right triangle, PRQ, this is a right triangle, and angle R, PRQ, this angle right here, is a right angle, and we've got a triangle. That means angle RPQ is also A. So this one's also A in there. Now, we have built everything that we need in order to prove these two formulas. Okay, so sine of A plus B. Remember at the start of the video, I told you that this angle put together, right, before I split it up, the sine was from P to B, right? So that is going to be equal to all of this, and I'm going to show you how. So let's look at P. We know O to P is 1. This distance is 1. From P to Q is going to be the sine of this angle, sine of angle B. Right? This length, because this is 1, this length right here is the sine of angle B. Okay? Because it's a right angle here, so then we've got PQ as the sine of angle B, okay? Then we've got OQ, right? From here, from O to Q, this is the cosine of angle B. Okay, so this is cosine of B right here. This is sine of B. Okay, now, if I wanted to determine what the sine of A was, right? So now switching to a different angle, sine of A being opposite over the hypotenuse, we would say that opposite would be AQ, right, over the hypotenuse, which is OQ. Okay, so let me write down some things here. All right. So we know PQ equals sine of B. Okay. We know OQ equals cosine of B. Okay, we know the sine of A is going to be opposite over the hypotenuse, and that'll be the sine of A. Okay, now OQ was also the cosine of B. So what we really have here is we have QA divided by OQ, which is the cosine of B, equals sine of A. So if I multiply both sides by OQ, what we end up getting is that QA equals the sine of A times the cosine of B. Okay? And that's because OQ is the cosine of B. So this right here, this is OQ. We can use this now we can use this small triangle here, okay, because this is also A right here. We can say the cosine of A is PR over QP, or over PQ. So PR over PQ equals the cosine of A. And that comes from this little triangle right here where my mouse is right here. So here's A, here's a right angle, right? So the cosine would be adjacent over the hypotenuse. PR divided by PQ, that's cosine of A. Now, before we said PQ was sine of B, right? So we're going to multiply both sides by PQ, and that's going to give us PR equals cosine of A times sine of B. Okay, because we multiplied both sides by PQ, which is the same thing as sine of B. So that got rid of the denominator here, and we get PR equals cosine of A times sine of B. So finally, okay, this length right here, okay, from P all the way to B is, well, from P to R, we already know that's cosine of A times sine of B. And we know from R to B, because this is a rectangle right here, we've made all these right angles, from R to B is the same as from Q to A. So if we add together the length from P to R and the length from Q to A, right, we add up this QA plus PR, that's going to give us from P to B, which is the sine of both A and B put together. So we can say sine of A plus B, sine of A plus B equals from P to R, which is cosine of A times sine of B, plus from R to B, which is the same as from Q to A, and we say here QA is sine of A cosine of B, sine of A cosine of B. And so that is how we get this formula, which is the sine sum formula. Two angles added up, you can determine what the sine is. So that's this formula here, just rewritten, so just flip those around. But that's this formula here, and you can do the same thing with minus b. You just use some symmetry, and you end up with this formula here as well. So I wanted to introduce you to that trigonometric identity because it's really powerful. It helps you to take the sine of two angles put together, and you now have a formula to do that. I understand that the video, you know, if you're not used to constructions and you're trying to put together a lot of things and making them fit exactly the way they need to fit in order to end up with a formula that's usable, if you're not used to doing that, this can seem like a very kind of heavy video, very intense video. In that case, what I recommend is just follow along, maybe with a piece of paper and a pencil. Watch it slowly, and just each new item that as I'm drawing it or as I'm explaining it, go ahead and kind of take your time and absorb it. It definitely, I made this, you know, take a couple of minutes, but to really understand it, you probably have to look at it and consider it and think about it and actually do it multiple times. Yeah, so have a great rest of your day.